This video will show how to run the equilibrium reconstruction workflow from scratch. Equilibrium reconstruction workflow is called Eqreconstruct, and the first step will be to look for documentation. So we open Firefox and we look for WPCD workflows.github.io. Then we go to the Eqreconstruct workflow and we look for installing and running the workflow. Right, so here are all the instructions needed to install the workflow, load the necessary data, and launch Kepler and run the workflow together with the settings there. So we will start from installing and running the workflow. We open now a terminal window and we copy the instructions here and paste. So this will load the IMAS environment. Then we do export the Kepler directory. Then we, if it's the first time, you will have to make a directory called like this. Otherwise, I do already have one. Then you go to the module switch, Kepler install, and Kepler load. Yes. And finally, you need to check out the workflow itself. Okay. And this will save the workflows in your home directory in eqstabil_workflow. Obviously, if you already have done this operation, the SPN checkout will not add anything. Okay, now just launch Kepler. First of all, here it tells you that you need to do the load of the version, which is this operation here. Control copy, paste, and then type Kepler. This will open the workflow. You go to open, then you go to home, look for Eqstabil workflows, and we will, in this example, we will look at equilibrium reconstruction for a jet pulse. So we open Eqreconstruct_jet. Now this is the workflow. There are several actors or complex actors. The first one that needs to be set up is start. Double click on start. This will identify the input file and also the output where the data will be stored. So this is the default setting. I will change it with my user and then the tokamak. So I have uploaded the magnetics and configuration for jet 84600 pulse in my input run 900, and I will select 9004 as my output file. The discharge, the equilibrium reconstruction will start at 50 seconds and will end at 52 seconds. And the work directory, the time step will be 0.1 second, the work directory will be 9999. Okay. Then the other actor that needs to be set up, these are all auxiliary actors. There's not really anything to set up here, but this one, reconstruct, needs to be set up. And here you can choose whether you want to have a free boundary equilibrium only, or you want to have also the high resolution equilibrium following the free boundary equilibrium reconstruction. In this example, we choose to have the free boundary equilibrium only. This will perform a magnetics only reconstruction. So here we can select the free boundary equilibrium code that we want to use. We have a set of equilibrium codes. The two which are tested and working at the moment are equal and is. So let's start with equal, commit, and we can reduce this to 51 seconds, and we can now start the reconstruction. So what the workflow does is it goes into the file, input file, it reads all the data related to the magnetic signals for this pulse, the wall IDS, the poloidal field active, PF active, the PF passive, the magnetic toroidal magnetic field IDS, and then based on those data, it will calculate the psi, so the flux map, solving the Grad-Trafalgar equation with the usual fitting procedure. So this is what you see on the left hand side, and this is the first reconstruction for 50 seconds. Then it will go on and recalculate the equilibrium reconstruction for 50.1 seconds. Here you see the psi map, the pressure, J, and the Q profile. 50.2 seconds. And while it does the calculation, it will store the data in the IMAS database, in my IMAS database under run 9004 as I selected. Okay, now the run is completed. The run has been successful. Now we can repeat the same calculation, but with a different transport code with NIS. We select NIS here, and we change the output run. We call it 9005. And we can now recalculate the equilibrium, but with this other equilibrium code using the same input file. So the input file is in my database, shot number 84600, run 900. Here you have the reconstruction done with NIS. Okay, so now the run has been completed. So we can close the workflow and we can look at the files generated. Okay, so you see 84600. The input file was the file 900, and we generated now with this run the files 9004, 9005. So if I open these files using Viz, we can browse them. So we look at tokamak jet, user G2M Roma, shop number 84600, and run number 900. This was our input file. And as you can see, the input file had the following IDSs filled in, iron core in blue. You see the list of total, all the list of the full list of IDSs, and in blue the IDSs which are filled with data. So we have iron core, magnetics, PF active, Thomson scattering, toroidal field, and wall. The equilibrium IDS is not filled, of course. Now, if we open the file that we have produced, 9004, is this one. Open. Okay, so it opens another window. And in this case, what we have is the same data as we had before: magnetics, PF active, T toroidal field, wall. The iron core is not saved, but the equilibrium is there, which is what has been calculated, in this case with NIS. Yes, so you see, fields are filled in. In fact, it's possible to launch the Equilibrium plugin. And the other time slice 1. You can see the profiles, psi, phi, f, the pressure profile, J toroidal, etc. And the same for 9005. Here. So all the data are there, ready to be analyzed. Same vacuum magnetic field, 11 time slices. And these are the 1D profiles. R inboard, R outboard, rotoroidal, rotoroidal normalized, etc. If you wish to see the files that were shown on the screen, the summary files, then they were stored in this directory here, eqstabil eqplots. Here we are. So you see these were created now for the different time sizes, and this will be possible to visualize them as usual with GB. Here we are. And that's it.